Now that our application is completed and running, we're going to prepare our app for submission to the Oculus Store. This module will help you understand Oculus virtual reality checks, or VRCs, where and how to find them, and the requirements for publishing an app to the Oculus Store. There are a set of guidelines that an app must meet in order to be approved for publishing on the Oculus Store. Once submitted, applications undergo an evaluation process called virtual reality checks by Oculus to ensure that everything available on the store meets a common and high-quality standard. It's important to note that these VRCs will update with the VR medium as it grows, so you want to be sure and reference the guidelines listed with the developer documents on the Oculus website, which you can find in the link below this video. As you can see, requirements range from app features including compatibility, performance, security, and functionality. All of these requirements must be met in order for an app to pass the Oculus technical review process. Fortunately, many of the technical requirements are handled by the Unreal Engine, but there are some VRCs that require considerations during development. As a general rule, we recommend that you approach testing VRCs as though you are the user, as the goal of the VRCs is to make your app an immersive experience for your users. This is a good opportunity to have your friends and family to test the app as well as to collect their feedback on how you ran. Now let's discuss each of the sections VRCs cover. Asset requirements. The first section of VRCs relates to the artwork you choose to upload through the Oculus dashboard to represent your game on the store. These graphics assets include a logo, cover art, and screenshots. Each of these assets have certain requirements that need to adhere to the Oculus Style Guide, which we have linked below for you to review. This content is often the first engagement your user will have with your app, so it's important to invest time and creative energy to ensure you produce high-quality supporting media. Audio requirements. There are only two audio-related VRCs. The first requires the app to automatically switch the audio output specifically to the HMD. This is taken care of for us automatically by the Unreal Engine, but is easily verified by booting up your application with your headset on and making sure you can hear it from the headset speakers. Requirement number 2 is a general guideline to support spatialized audios when available. It's good practice to spatialize all diegetic audio, or audio that occurs from sources in the game world. The Oculus HRTF is specifically built to extend the built-in Unreal features and improve immersion. Compatibility requirements. Generally speaking, compatibility requirements are taken care of automatically by the Unreal Engine. But to be certain, always make sure you're using the latest version of Unreal Engine with the latest Oculus SDK integration and support. Although there is support for legacy titles in each Oculus SDK update, new titles require the latest version. Functional requirements. The functional requirements section has a broad list of requirements. These VRCs are here to ensure consistent behavior in all Oculus-supported apps. The topics covered in this section are designed to help you make sure your app is a high-quality experience for the user. These VRCs ask that you make sure your app does not freeze or crash, tracks the headset's position and rotation, pauses when in single-player mode, does not randomly lose any player data, does not trap player or leave them stuck in a certain point of the experience, is playable from a desktop if it supports desktop mode, and does not contain any non-Oculus HMD in the stored imagery. This ensures that games in the Oculus ecosystem provide a cohesive and enjoyable experience. If the way your app runs is predictable and similar with other titles, users will find the experience to be more intuitive. But if, for example, the user takes the headset off and the app were to not pause and something completely unexpected happens, the feeling of consistency, thoughtfulness, and immersion can be quickly lost. Input requirements. The input section lists a few requirements that help create consistent input behavior in the Oculus ecosystem. There are specific buttons and interactions that are only meant to control the Oculus Dash. We are not allowed to override these inputs. For example, users should always have the ability to step out of an application to interact with the Oculus menus. So the menu button on the right touch controller can only be used for this purpose. In-game menus will need to be mapped to the left touch controller's menu button. Another example is to reserve the interaction of picking up or holding an object to the grip button on the controller. This way, the user will already be comfortable with the controls when they hop into the experience. You also want your application to pause while the dashboard is open for single-player experiences. This way, the user doesn't check their dashboard and hop back into their game, only to have lost all their progress, missed a cutscene, or important dialogue because the game kept running without them. That said, if the app is focus aware, then it must continue rendering but ignore all user input. An exception here would be for multiplayer experience. You don't want the whole online session to pause if one person decides to remove their headset, as it will ruin the experience for everyone. You just want to make sure your application pauses when the user is in a single-player environment. And of course, you want to make sure that the in-game hand's position and orientation line up to the user's real-world hands as accurately as possible. If a user tries to grab an object and their hand rotates into an awkward position that does not accurately match the position of their real-world hands, it will break their immersion and probably feel uncomfortable. Performance requirements. Like the functional requirements, performance is a broad section in this checklist. Performance in VR is crucial to maintain a high level of immersion. Once performance falls below a certain threshold, user retention rates have been shown to fall dramatically. Low-performing apps not only look bad, they may also be uncomfortable to play. We want to ensure that our app meets all the performance criteria in the VRC guidelines so that our users experience the highest quality VR experiences possible. You also want to make sure that your app launches quickly and has no issues with the user's vision. Distortion and Z-fighting are common vision problems. Head-locked UI elements should be rendered in the compositor layer so the user does not see any juddering while the game loads. Issues with performance can be identified with profiling tools covered in this project's previous optimization courses. For PC VR, you will also want to make sure that your app can sustain frame rates of 80 FPS on Rift S and 90 FPS for Rift while running on an NVIDIA 970 GPU and an AMD 290 GPU, as these are the graphics cards that Oculus QA will be testing performance against, and is a common area where games fail to meet performance requirements. For Quest, you will want to make sure your app can run at 72 FPS. Oculus QA will be using Oculus debug tools to determine the performance of your game, so it is a good idea to use Oculus debug tools as a final performance check before submission, which you can find more information on in the link below this video. Security requirements. The security requirements section covers safety measures for users and developers, the first of which is what's called an entitlement check. This functions as a check for ownership through the Oculus Store. The entitlement check is built into the Oculus SDK integrated into the Unreal Engine. We are tasked with implementing a short script into our blueprints, which was covered in the first course of this learning path. More on this topic can be found on the Oculus developer website, which we have a link below. Testing your app's entitlement is an easy process. All you need to do is log out of the Oculus client and boot up your app with its executable. The other requirements are there to ensure that your app isn't bloated with anything other than the app itself, such as marketing assets, the Oculus VR SDK, or the files produced from debugging and troubleshooting. Developers will only need to rely on the Oculus API for the entitlement check. The complex problem of checking ownership of the software in a variety of internet connection states is taken care of by the system. Tracking requirements. The tracking requirements section only includes two checks. One is to correctly label your app as either sitting, standing, or room scale. The other is to correctly label your app as a front-facing or 360 experience and implement that setup within your experience. And that covers what to look for when reviewing your app for a submission to the Oculus Store. Congratulations! You have reached the end of our final course in this learning path. You now have an understanding of how to build and test a VR app built with Oculus in the Unreal Engine. Thank you for taking the time to complete this learning path. We look forward to seeing the apps you will be making.